So in the previous video we had seen about the newer features of C++. Okay, so for now we'll be starting with the basics of C++. Okay, so the advanced features we might see in the newer videos. Okay, so let's just start with the first program, that is the first.cpp. Okay, so as always the first header file that you include in C++ is iostream. Okay, so iostream provides the input output stream functions, that is the cout, scene and all these things are provided in iostream. So in modern C++, the thing that has changed is you can no longer write void main. Okay, so in the previous programs, if you have seen some Borderland C++ programs or that sort of a thing, you had a void main. Okay, so newer standards enforce that you cannot write a void main. The idea behind not writing the void main is that the program should have a graceful exit or any sort of exit. Then it should let know the operating system that it has exited and provide some certain error code or a success code, which is usually return 0 that we do. Okay, so if your program is not returning any code, then debugging becomes a major problem. Okay. So apart from that, in some cases we also enforce this format of command line arguments. Okay, so command line arguments predominantly will not be using in early programs. Okay, so that's not a problem. Okay, so this is a basic, what you call a skeleton of a C++ program. Okay, so C++, unlike Java or any other what you call OOP based languages, is not enforcing the kind of OOP you would say. So you could write procedural based imperative programming in simply this thing in C++. So you need not use classes or any sort of thing. So now to write cout, previously we could write simply cout and display this message. Okay, so this message, so you could simply write this thing and do. Okay, and we just save this thing. So now if we hover over these two things, then it will show you as cout as undefined. So what has happened is there is a concept of namespaces that has been introduced since C++ 3 2003 standard. Okay, older versions of C++ did not have the kind of namespace sort of a thing. So all the functions or the variables on these things that were publicly available were part of the global what you call the global namespace, that sort of thing. So now there is a main global namespace which is called standard, which is std. Okay, so std, and here also you write std, so that way you can get rid of those errors. Okay, so now that you have written simple program, so how do you run this program? Okay, so the first step is actually how do you compile this program. So in the previous video I had shown you the approach using IDE, but I thought for the initial days we could start with G++ directly, then we'll use the IDE based approach. Okay, so G++ -o, there is the output file name. Okay, here I can write first and first.cpp. Okay, and this will generate a what you call executable or binary file for this thing. Okay, so you can run this thing and it will display the message. Okay, so while learning any kind of programming language, the data types play an important role. Okay, so specifically for lower level languages or languages like C++ and C as well. Okay, so data types here behave sometimes weirdly. Okay, so you need to be very careful when dealing with different types of data types. Okay, so for those who are new to C++, so basically data types, or I could tell you the concept of data types. So different types of data is processed or churned out of a computer. So there are certain data types, or you could say the types of data we could identify. So for numerical data there are predominantly 3 major types. Okay, so one is called an integer, which does not have any decimal values. Okay, then the second type of data type is float. Okay, so float allows you decimal values. Okay, and there's another data type called double. So double, the idea of double is the range of double is twice of float. So usually a float is of 32 bit equivalent to an integer usually. Okay, so this double is 64 bit. But now the kind of language that C++ and C have evolved to be, the size of the data types that are defined, like if you say int, okay, and you say some name, so like n1 or number one, that sort of thing. Okay, so across the system you cannot guarantee that this size will be same. So this size of the data types can change. Okay, so what should you do when the size of your data types changes? Because you need your program to be uniformly running across all the systems, so it should be running on across all the systems. Okay, so C++ has this issue. So there are some kind of, you could say, data types defined that have fixed sizes. Okay, so what you could do is simply, you could declare this thing as std int 32 underscore t. Okay, so this will create a 32-bit integer only. Then there is 64-bit int as well. Okay, so this is a signed integer. Okay, so what exactly is a signed integer and an unsigned integer? So another important part that we need to know as C++ developers is how data is stored and what exactly is signed and unsigned. In other languages also you might have a signed and unsigned integer, or that sort of distinction. So we'll start with a very small data type. So just say we have a very small data type which has 8 bits. So I have written a uint 8. Okay, so uint 8 can have a maximum value of 0xff, which is equivalent to decimal 255, decimal base I mean. Okay, and in hexadecimal it is 0xff. Okay, so this is the integer 8. So now when you say unsigned integer, it will be 255. So this 255 in binary can be represented as follows: 4 ones, again 4 ones. Okay, so this 8 bits make up the field as 255. Okay, so if you have learned about microprocessors, so there is a concept of sign bit. Okay, so there are two types. Okay, so when we work with integers or any kind of numbers, we have positive numbers and negative numbers. So like we could represent like minus sign, with a minus sign we could represent some number. So what the computer does is, it does not have any extra bit for with it to store the sign. So what it does is, the highest bit, that is the most significant bit, so this is the least significant bit. Okay, so the farthest right end is the least significant bit. Okay, and this one is the most significant bit, the leftmost bit. Okay, so the MSB stores the sign. Okay, and what happens is, due to this one bit being reserved for certain operations, we have only 7 bits with us. So using those 7 bits, if we convert this thing, so then it is equivalent to 127. Okay, and this bit, depending upon whether it is 0 or 1, the sign will be positive or negative. If the bit is 1, then the sign is negative, and if the bit is 0, the sign is positive. Okay, so this is the concept of signed and unsigned. I hope this should have cleared a certain degree of confusion that exists when people start learning programming, what exactly is signed integer and unsigned integer and how internally it is stored. In other programming languages where we might not need things like bit manipulation or any sort of a thing, we need not care about how exactly signed or unsigned integers are stored inside. But C++ and C make a certain case, you could say. So for that purpose we are learning this part. Okay, so for every value, you could say, so what happens is, like, the range, overall range. Okay, so for an unsigned integer of 8 bit, the range is 0 to 255. 0 to 255, sorry, 255. Okay, so this completes a total of 256 bits. Okay, so 2 raised to 8. So now, as you have only 2 raised to 7 bits, so now the range has been reduced to minus 127 to plus 127 or 128 in some cases. Why that plus or minus 1 you have in this range? So usually it is plus in this range. Okay, so some cases you have here 128 and here 127. So how these things manage, that we will see in some other video. Why it is on some parts it is plus 128 and some cases plus minus 128. So like one bit is unbalanced over here. Okay, so usually that is how range is represented. Okay, so this is how signed and unsigned the difference. Okay, so any number you are taking. Okay, so here this was simply I have taken unsigned integer n1. So like I know this course is for slightly advanced people, like not exactly you could say extreme advanced, but slightly people who have learned programming and now they're venturing into C++. So the target audience is certainly kind of people who are a bit acquainted with programming but not quite acquainted with C++. So that is why I'm going into the intricacies. So people who might find this boring, like as beginners, maybe you guys can skip it if you want. Okay, we might get to this part afterwards. Okay, so now I have assigned some value, say 10. Okay, and here if I assign say 100, and now if I do equals to n1 into n2 and stdc out, is let's recompile this again. Okay, so now it is showing the multiplication is 1000 and it is the right answer. So what happens if I change this to uint 8? As I said earlier, the maximum value a uint 8 can show you is 255. So what happens over here, that we will see. Whether compiler gives us any warning. No, it doesn't give any warning. It is not rushed, so it's not giving any warning. So we'll run this thing. See, now it is giving you some random value. The thing is, you cannot directly display what you call uint 8. Okay, so I'm taking uint 8 for a reason, because other data types, with other data types, overflow and all these conditions can rarely be observed when your program is actually running. So just to get you acquainted with all the problems that you might face. Okay, I'm just typecasting this result. Okay, so it will not change the result, it will just typecast whatever is shown over here. Okay, see here, so it is showing you the result 232. Okay, so what exactly is happening is it will roll over. Okay, so what exactly is the rollover? So like now the value is 1000. So one range was 255. Okay, so 1000 is like 4 times 255. Okay, so that's how it reached at the 4th iteration, okay, of this thing, and it has shown us the value of 232. So it has almost reached the 3rd iteration, 4th iteration it has reached. Okay, so if you just the range of this thing 255 4 times you could do, and you could just simply minus that last one from this thing, you will get that value 232. Okay, so that is how overflowing takes place. Okay, so bits are just shifted over here, so you will not get an actual error sort of thing, because it will just shift these operations. Okay, so you need to be careful how and what data types you take whenever you're programming. So now another data type that has been used in C++ that you might not find in you could say older versions of C++ or C is the string. Just okay, so just take any string, enter string. Okay, so now it will ask you for the string, so you can insert anything you want. So this string basically, the difference between the classic string, or you could say the character array that we use in the older versions of C++, is that this string is not terminated with the \0. Means it need not be terminated with a \0. So previous copy operations, like if you have heard of the functions called strcpy or that sort of a thing, so what they used to do is, like in original C++, what used to happen is, whenever you declare a string, it was basically char str and this thing 10. So like string of capacity 10, not exactly length 10, there is a capacity of 10, and if you assign something to this string, just say if you assign test to this string, or you could do scene. So what the compiler used to do is like, or whenever the runtime used to do is, the string test which was appended by a \0. So this used to be a terminator for the string or delimiter for the string to understand where the string ended. Okay, so what happened was, and also during computations of different types, like if you want to copy some string or if you want to append some string, so people used to write their own functions which were buggy sometimes, and what they used to do is they used to override this thing and write some other string, and they forgot to put \0 at the end of it. So what used to happen was, like, you would get into a segmentation fault because you accessed a non-existent memory location for the program. Okay, so that was the case previously. So now C++ has that kind of safety net, you could say, wherein your string is not exactly as volatile as it used to be. Okay, so let's see what happens. So whenever you type this thing, so like it has its length function, which is not exactly dependent on what you could say the \0 or the delimiter sort of a thing. So pretty much sophisticated part that exists in C++ these days. Okay, and let me show you the length. Okay, length. But the downsides that come for this kind of implementation is related to the space constraints. Okay, so as pretty much all the memory management over here for this data type is done by the string class. Okay, so that is why it becomes pretty much difficult to optimize the std string. Okay, so there are a few methods that make it a bit optimal so that less and less copy operations could take place. Then there is something called as move semantics that helps as well. Okay, so we will discuss about move semantics. So this was just what you call a warm up for getting into move semantics. So in the next video we'll be learning about move semantics, just so you have a hint of how exactly things go and what exactly things cause, just so that I'm giving you a hint for that. So see, it will give you the length of this thing. So now all the sophisticated methods are available, but the price for all this is it has a lot of copying that takes place. Okay, so now if you assign something to the string, so there will be a copy of the string that will be created, and there that value will be assigned, or that sort of a thing. So there are few mechanisms that have been involved, or you could say evolved, sorry, which help in what you call optimizing all these things. So we'll see about those mechanisms. So this was just like a brief, you could say, intro to how C++ had changed over the years. Okay, so the first part was also an introduction. This was you could say kind of warm up, and from the third video we'll be actually delving deep into the features of C++. Hopefully this video was a bit chaotic, but I suppose this should give you some hint of like how C++ has evolved. So like that was the what do you call, the main this thing idea of this video. Okay, hopefully we will be learning about things in depth in the upcoming video. Okay, thank you.